time, and that's where we are now. Welcome to BCTV yet again today. The toll for COVID cases cumulatively is now 73, and that is because 77, and that is because of the new cases that we got yesterday, the 11 cases, seven Tanzanian truck drivers and 5 Kenyan truck drivers, 3 of those at the Malaba border and 2 of those at Busia border, and the 7 Tanzanians at the Mutukula border. So that is where we are, and we continue to count and get there. But one thing that we want to appreciate that the pandemic has actually brought out so much innovation among us Ugandans. And just right this morning, we now again want to introduce to something that is very new, and this is learning at home. None of us knew that maybe learning at home would be easy. And of course, we are learning what will happen in the new normal. In the new normal, I think this is the way to go. Now, with me in studio this morning is Mr. Gilbert Sima, Gilbert Sima, a curriculum expert from the NCDC here in Uganda. You're very welcome.
Well, thank you.
I thank you so much for joining me. And of course, what we're going to do this morning here is we introduce to you PICED, a company that is limited and a local technology company that focuses on teaching secondary schools. And PICED, of course, is a subsidiary of PICFair. PICFair, it is only thing. PICED means PICED, I think, is PICFair Education.
Yes. PICED is PICFair Education, so they are focusing mainly on extending education services, this time with emphasis on integrating technology in the teaching and learning. Because, as you know, Uganda is undergoing a 4th industrial revolution. There are a number of things that are coming up. So PICED is making every effort to make sure that as technology advances, education is not left behind, and Uganda is not left behind as far as integration of technology in education is concerned.
So what new thing that is special that PICED is actually giving to us or giving to the people who are watching us now?
Something special that PICED and NCDC, because we are working together in that area, is that we are coming up with a way of teaching STEM. We are trying to come up with an emphasis on STEM, STEM standing for science, technology, engineering, and math. This acronym is now a worldwide acronym, and it is a measure of the quality of education across the globe. And PICED, together with NCDC, we are trying to strengthen those areas, because most of our subjects, you've had the president emphasizing sciences, they all come from that STEM. So PICED with NCDC, we are trying to strengthen that area of STEM. Using technology to reach out to people, we are trying as much as possible to simplify this technology to make sure that whether you are in Koboko, Busia, Mbale, Kampala, we reach out to you. Definitely it will not happen overnight, but we take one step at a time.
Okay, because I know that NCDC, you are the overseers of the curriculum in this country. And should I now assume that what PICED wants to give us through their STEM project or STEM program is accredited by the National Council for National Curriculum Development Center?
Thank you. NCDC is in charge of quality management alongside other agencies of the Ministry of Education. So our main concern is on curriculum and curriculum materials. So when any private company wants to develop something for education, for our consumption as Ugandans through education, and it is within the limits of pre-primary, primary, and secondary education, ideally it is good that you channel it through NCDC for verification and making sure that it is of quality and in line with the curriculum. So that's why PICED felt that whatever they are doing, they need to go through NCDC such that we look through what they are preparing and then share it with the Ugandans.
So does that mean we have to trust everything that PICED gives to us? When PICED gives to us anything, we trust that that has gone through your sieve and it's actually good for consumption?
When PICFair shares something that has gone through our sieve, you will find it inscribe that we have approved it.
Okay. Well, thank you so much. Now, because people are actually home listening, I want us to demonstrate what you actually do with Pick Ed. And you just talked about something. What new thing is this? You talked about coding. I need to get to that because I'm a nuts man. I am a nuts man. The president was talking recently and he said, these Shakespeare's, we are the Shakespeare's of this world. We are not the scientists, so we are the Shakespeare's. So I help with the Shakespeare's to actually understand what you're calling technology coding.
Okay, coding is the language of computers, if I may just say it that way, for the sake of a layman's language.
Okay.
The language of computers is what is used to develop the programs. Now, if you use Microsoft Word, there is someone who went behind the scenes to develop that Microsoft Word to make sure it behaves the way it does. And that person did coding. Now, you realize that previously, those who have gone through universities and have done bachelors of computer science, bachelors of information technology, and other related courses. The coding that we did when we went to university was you have to write a line of code. If you forget a comma, done. It's wrong. But now, over time, with improvements in technology, coding has been simplified. And coding can be done even at primary, as low as primary 1. So it's that we are bringing on, such that when you go to wherever you go, you can look at something and develop a solution using the coding languages that are available.
I would like to Mr. Sima to actually demonstrate these things to us. I just want to give you much of this time without my interrogation. I'd actually also do the learning. Please, will you take us through what you have, because I know that you have some slides here to help us understand what you are saying. Welcome to teaching us these things this morning.
Okay, thank you very much, Mr. Semakula. Actually, I also enjoyed the discussion, but now let's switch to learning. And in my lesson today, I am going to teach a topic called number bases. Number bases is a topic that we study that is on our curriculum from primary, starting around primary 4, primary 6, primary 7. We look at number bases. And when we cross to secondary schools, we still look at number bases. Now, that's where curriculum comes in. It is arranged in a series such that along the way you can pick what number basis is all about. Now, in your primary school, you have learned about counting, for example. And all the counting that you've done it and you've done it very well. Take an example when you count money. Take an example when you count the number of steps you've taken to move from one point to another. Have you done any measurements? You used some numbers. And in today's lesson, we are going to make sure that we are going to look at identifying the place values of the numbers that you use. We are also going to represent the numbers on the abacus. We are finally going to convert numbers from one base to another. As we do this, I request you to look around you. There are some things that you can use to do some simple counting. They can be bean seeds. They can be maize seeds. They can be pieces of sticks. They can be anything that is near you that you can use. So if you can get about 20 of them that are very close to you, that will be helpful during the course of our lesson. But as you do that, remember, we are in the COVID period. You need to wash your hands regularly with soap to make sure that you are not infected with the coronavirus. Now that that is done, I hope you've picked something that is very close to you. It doesn't have to be something that is a specific counter in a certain way. Let's look at what we have prepared. Counting in base 10. When you are counting in base 10, you used a number of digits. For example, you can see these are the digits that you have been using. 10 of them in number, from 0 up to 9. And that is counting in base 10. Every other number that you have used, whether an amount of money or the area of your piece of land, or the perimeter of your exercise book, or your height as an individual, has been got from these digits. These digits are from the Hindu-Arabic system. And these digits, we use them every day. And we use them in base 10. Now, let's try to understand what base 10 is all about. These digits, I have a 0 on screen. And that shape around it is a placeholder. Each of these digits uses strictly one space, as shown on the screen. When we have nothing, we call it a 0. But look at this. When you have 1, take the 1 on the left to be the counter. When you have 1, we indicate that it is a 1. And if you run through, as the counters increase, also, we are still using one space. One space until we reach 9. Now, at this point, we get a challenge. Our space holder can hold only one digit. But we know there is a number called 10. So what happens? What happens is that we get another counter which is not yet added to the 9. And this counter, when we add it to the 9, we make 10. But this 10 is bundled up such that we form a bundle and this bundle is what we write as 10. In other words, 10 is a bundle of counters grouped. We have formed one group of 10, and this one group of 10, we do not have anything else to add to it. That's how we come up with 10. And as we continue counting, you'll find that now I'm showing you how we build from 10 to others. What we have on the left, the number 1, is counting the number of bundles of 10, and what we have on the right is showing us the number of what we've referred to in your primary school as ones. Take an example. The figure showing on the screen is showing you 1 in the place value for tens and 5 in the place value for ones. Now that the ones place value we have changed to 6 and so on. Now when we get to 19, we encounter the same challenge, but we already know that we can get a bundle. So we can continue and have that counter added. That's when we get another bundle. That's how we come to 20. And the process continues until you reach your millions and whatever you want to do. Now, I'm going to show you a video, and this video is going to quickly simplify for us what we have referred to or what you have learned as place values. And these place values is what we use to count all the numbers that we have come across. The place values of ones, tens, hundreds, and so on. So may you please enjoy the video, and I'll be back immediately after this video.
As seen here, is an instrument made up of spikes and beads. Numbers represented on a spike abacus help us better understand the number and the place value of its digits. The spikes from right to left represent place values, and the beads are used for representing the digits. Here we see an example of an abacus with 3 spikes. The spike on the right represents the ones place, or units place. The second spike from the right represents the tens place, and the third spike from the right represents the hundreds place. Let's learn how to identify various numbers shown on this spike abacus.
Here we can see that on the first spike, which represents ones, there are 6 beads.
On the second spike, which represents tens, there are 3 beads. And on the third spike, which represents hundreds, there are 5 beads. 6 beads on the one spike represent 6 times 1, which is equal to 6. 3 beads on the tens spike represent 3 times 10, which equals 30. And 5 beads on the hundred spike represents 5 times 100, which equals 500. So the number formed on this abacus is 536. Likewise, the number represented by this spike abacus is 821. Let's try to represent a 3-digit number on our spike abacus. We'll use the number 472. The digit 4 represents 4 hundreds, 7 represents 7 tens, and 2 represents 2 ones. So we'll put 4 beads on the hundred spike to represent 4 hundreds. We'll put 7 beads on the tens spike to represent 7 tens. And we'll end by putting 2 beads on the one spike for 2 ones. Now let's learn how to use spike abacuses with 4 or 5 spikes. From right to left, the 4 spikes represent the ones place, the tens place, the hundreds place, and the thousands place of a number. From right to left, the 5 spikes on the abacus represent the ones, tens, hundreds, thousands, and 10,000 place of a number. Let's identify the number shown on this spike abacus. There are 8 beads on the one spike, 4 beads on the tens spike, 1 bead on the hundred spike, 3 beads on the thousands spike. So the number shown is 3,148. Likewise, the abacus with 5 spikes represents the number 29,751. Now let's try representing a 4-digit number and 5-digit number on our spike abacus. First, let's try the number 9,604. The digit 9 represents 9 thousands, the 6 represents 6 hundreds, the 0 tells us there are no tens, and 4 represents 4 ones. So we need to put 9 beads on the thousand spike, 6 beads on the hundred spike. Since there are 0 tens, we don't have to put anything on the 10 spike. And we'll put 4 beads on the one spike. Likewise, to represent the 5-digit number 16,395, we put 1 bead on the 10,000 spike, 6 beads on the thousand spike, 3 beads on the hundred spike, 9 beads on the 10 spike, and finally 5 beads on the one spike.
Thank you very much. I hope that has been refreshing to you and you've been able to just remind yourself of the abacus, and to date it is still very important. Now, as we look at base 10, we have learned that we have used only 10 digits. Base 10 uses only 10 digits that are showing on your screen. And base 10 also, we can form any number by combining any of those digits. And also, we have also seen that base 10 counts in groups. For example, at 10, a group is formed, and that helps create another place value. The same thing happens at 100, at 1,000, and the rest of the place values like you've seen in the video with the abacus. Now, we say that you are going to convert to other bases. Now, let me use base 6 as an example. If I'm to convert to base 6, you'll find that I still have the same principle of the counters. But like we've seen that base 10 has only 10 digits, in the same way, base 6 will use only the first 6 digits. And when we reach 5, we can't go any further because this is the 6th digit. Therefore, we have to use the same approach of grouping. Group, and then we form numbers in base 6. So that now, at 6, that's when we get 1, 0. Unlike base 10, now this one will be 1, 0, base 6. And the process continues. If I can run through quickly, you'll find that I'll have 2, 5 in base 6. Please take note. When it's base 6, you cannot say 25. That is 2, 5, base 6. 25 applies when you are in base 10 because it is tens, hundreds, and so on. But this is 2, 5, base 6. Now, when you are to represent this on the abacus, it is slightly different, but highly related to what we've just seen in base 10. For example, let me just populate my abacus. When I reach 5, like we've seen, then I have to form the bundle of 6. So this green bead represents a bundle of 6 counters. And the process continues like we have been able to see using the abacus. Now, this is the difference between base 10 and the rest of the bases. We still have 1s in base 6 or any other base that you can think about. But when we come to what we had as 10's place value, this time in base 6 we have 6s. And the next is 6 of 6s. Now, if you compare with what we had previously, you find that where we have 6 of 6s, in base 10, we had 100s. But now it is 6 of 6s because it is the same as 6 times 6. We had 100s in base 10 because it was 10 times 10. The next place value is 6 of 6 6s. Previously in base 10, we had thousands. But now, in base 10 thousands, you arrive at thousands because it is 10 times 10 times 10. So that place value will be for 6 times 6 times 6, and so on and so forth. So that's the slight difference between base 10 and the rest of the bases. Now, this one, if you're to compare with base 10, you'd find that this one uses only the first 6 digits, 0 up to 5, and any number in base 6 can be formed using a combination of only those 6 digits. And finally, at 6, in base 6, we form a group. So that's the only difference between base 10 and the rest of the bases. So if we are, for example, in base 4, that means we would form our group at 4. If we are in base 8, then we would form our group at base 8. Now, I know you have been eagerly waiting to try out something. Right now, we are locked down in our homes, but we can still learn from our homes. Now, try this one out. Express the number of people in your home in groups of 2s. This is the same as base 2. Now, you might be 3 people in a home. Can you try to do the grouping such that at the end of the day, it is expressed in groups of 2s? If you're 9, the challenge is on. Make sure that you express in groups of 2s because the base 2 uses only the first 2 digits. That is a 0 and a 1. I know you're trying that one out. You can write it down. You're going to keep trying it out. And when we come back on air sometime to come, then you'll be able to share with us what you finally came up with. Finally, we need to be concluding. We have a few minutes left, but we are going to end by converting from base 10 to any of the bases. If you are to convert from base 10 to any of the bases, you've already seen the difference between base 10 and base 6 as an example. So if we are to convert from base 10 to any of the bases, the base is all about regrouping. So if we are to group, can we look at this example now and see how to group? I have 19 base 5. Sorry, I have 19 base 10, and I need to convert it to base 5. Please take note. When a number is given as, say, 19, without stating the base, that is automatically in base 10, because it's a base we use in our everyday life. But other bases, base 5, base 4, base 6, base 8, base 9, we don't use them in our everyday life. So it's important to state that you are using a base different from what we use in everyday life. So we are going to use a method of regrouping. If we are to regroup our 19 base 10, now we can form a bundle of 5. But we still have very many more counters that are not yet used. So we can form a second group of 5s. With the second group, we still have very many more counters that are not yet put to use. We have a third group. These 5s, all of them add up to 19 counters. That means we add up to 15 counters, sorry. That means we still have 4 counters left. But 4 is not enough to form a group in base 5. So we can put our 4 here. So all the counters that we had on the left have been utilized, and they are all on our screen on the right. They are all represented and have all been regrouped. So in the end, we have 3 groups of 5s and 4 other counters that we haven't been able to group because they are not enough to form a group. So this can be written as 3, 4, base 6. So converting from one group to another is all about regrouping. You just form a group based on the base that you want to use. As we come towards the end, you might need to look out for the mathematics in all this. You might be asking yourself, so if converting from base 10 to any other base is all about regrouping, where is the mathematics in this? This can be done mathematically using this approach. If you have 19 and you divide this 19 by 5, you will quickly get 3, because 3 times 5 gives you a 15, and you have a remainder of 4. And this, at times, some other people write it like that, to mean 19 divided by 5 gives you 3, a remainder of 4. So mathematically, it shows that if I get 19 divided by 5, I'm going to get 3 groups of 5s with a remainder of 4. And this is the same as 3, 4, base 5. Let me convert to base 3. When I convert to base 3, you realize that 19 divided by 3, I get a 6. Remainder 1. And 6 is bigger than 3. We are converting to base 3, and base 3 has only the first 3 digits. That is a 0, a 1, and a 2. So we cannot have a 6 in this. So we divide it further. I again get 6, divide it by 3 to give me a 2, remainder 0. 2 can be part of base 3. Now that we've reached this point, we can comfortably stop at this and say, this is the alternative approach. So if I convert 19 base 10 to base 3, I am going to get something like 201 base 3. Why 201 base 3? Because we are starting, do you see the arrow on the right that shows you 2 remainder 0? So you start from that and you write what you've got backwards until you finish all of them. And that gives us 201 base 5. So there are some other examples that I have done to convert, but you can try this one out in your living room. You can convert 19 base 3 using counters, 19 to base 3 using counters. It will still give us the same figure. But the only difference is, at first we had 6 groups of 3, but we cannot write it like that. So we regroup the 3s, we again group them and have something like that that is showing on your screen. So as we conclude this lesson, we have been able to convert numbers from one base to another. And we have also identified place values in different bases. We had an example of place values in base 10 that we used on the abacus in that video, but we also had another abacus in base 6 where we had 1s, 6s, 6s of 6s, and so on and so forth. And we are able to represent all our numbers on the abacus. And as we conclude this lesson, please try some of these questions that are showing on your screen in your exercise book. And that has been our lesson for today, Number Bases by Sima Gilbert, with support from PIC-ED, which is a subsidiary company of PIC-FAIR and National Curriculum Development Center. Thank you very much.
Well, thank you so much, Teacher Sima Gilbert Gift, and a curriculum specialist from the NCDC here. And of course, well, I want to appreciate that, first of all, it has been very interesting. I've enjoyed it. My understanding is actually what you shouldn't get into, because it was not compulsory actually for me to understand. I understood what you did.
Well, yes.
But it was a very interesting, it was very interesting.
Did you know that bases were just about regrouping?
How would I know? I don't remember when I last studied mathematics.
So,
I studied mathematics because it was compulsory.
Exactly.
And I thanked God when I got to senior 4 because that was the end of my math.
If you were born late, now you'd still be doing subsidiary mathematics.
And that's why I thank God I wasn't born late. I was actually born the time I was born to be there. So
yes, so we are up to simplifying mathematics actually.
I love numbers because I love counting money. So my mathematics is actually money. When
Yes.
you give me, I can't miss
Yes.
out. I can't miss out on money figures. But I want to thank you so much. It's
You're
been
most
very
welcome.
good. And
Most welcome.
well, now, for what level is this now? What level is this?
Now, this lesson spans from around P6
Okay.
up to senior 2. Our curriculum, when we're developing curriculum, it has a spiral approach. We get a concept and build on it, such that the teacher keeps adding on and adding on and adding on. That's why this lesson spans from P6 up to something like senior 2. Now, a P6 child can benefit from this lesson. An S1 child can benefit from this lesson. But I picked it from the senior 1 syllabus.
Okay.
Of the reformed curriculum.
Of the reformed curriculum.
Yes.
That's very important. Now, well, one, I am very amazed at what the Curriculum Center is actually doing. the development center there. But I'm also actually very overjoyed by what PICED is actually doing, because this is a very good innovation. I do not know whether PICED intends to reach to all of us, because I am only thinking, how many of us have internet, how many of us can access these, because I see PICED trying to take us into digital education or digital learning, which is actually the way to go, and very important. Now that we are not in classes, we are not in schools, we can actually learn these things from TV, from screens, and anything. I don't know whether PICED can reach all of us, because I do not think all of us have internet and TVs in the houses.
Not all of you have internet. I was shocked to learn the other day that some of us who have TVs do not have radios.
Is that so?
Yes. People who have TVs do not have radios.
And it is cheaper to have a radio than
yes,
have a TV.
Yes, it is cheaper to have a radio than to have a TV. Than a TV. Now, you say that you are a literature person, but you know that in a subject called economics, there is demand and supply. Some of these things have not been on demand because they were not there. Some schools have had computers, but they have not used them because they have not had digital materials to use on the hardware that they have. So it's some of those that we're trying to close. And some of the up-country schools have had these computers. They have not been able to use them. So we are trying to fill that gap such that there is actually a demand. And definitely we cannot keep where we are forever. We never knew that we would need telephones some time back. But now everyone needs to own a telephone. Why? The reason is simple. There is a service that is extended through telephone. So we need to make sure that the services are available, and that alone will create the demand. And will also enable the government to reach out to people through this channel.
Well, I think I also want to thank PICED, because I am told they are planning to give us some free online material for us to delve into and, of course, to study. And I think I want to thank them so much. And this is why I actually told my colleague here, Ruben, before he left the studios, that one of the things that God has given to us through this pandemic is it has brought out all these innovative skills within us to actually see how to manage. Because if we are kept indoors, that does not mean we should shut down life, we should stop living, we should stop drinking and breathing and doing all the things too. For as long as COVID hasn't killed us, then life has to continue. And life has to continue as we're learning, as we're studying, as we're innovating and doing all the things. I want to thank you so much, Mr. Gilbert, Gilbert Sima. And of course, I also want to appreciate PED for PICED, I beg your pardon, PICED for bringing this to us and for endeavoring and ensuring that they actually do this. And I'm also happy that they've partnered with the NCDC, so I'm very sure that whatever materials that will land on from PICED, that will be authentic material. It shall be material that has gone through your sieve. It's material that you've allowed for children to actually consume. And I think this is very good. We will give them our support whenever necessary to see that we actually now find means of teaching our children from wherever they are. Thank you so much, Mr. Sima. And I also want to thank PICED for allowing to give us this opportunity to teach our children from their homes, wherever they are. Now, our time has run out, and I'm also being told there will be another mathematics lesson again for now the P7 students or P7 candidates here on our next program, which is Candidates 2020, and Teacher Wilbrod will be teaching mathematics P7 or teaching P7 candidates some mathematics, but we also might interrupt our normal or usual programming just in case anything steps up. If anything comes on, we expect to interrupt the normal transmission again for different updates. My name is Jagenda Semakola Ziksoka. Thanking you so much and wishing you a very nice weekend. Good morning and bye for now.